Hello and welcome to my creative assignment 4. The purpose of my experiment was to demonstrate and calculate velocity in a moving frame. So my goal was to create an experiment in which I have a moving frame and a point moving on that frame and calculate these values to find the velocity of that moving point with respect to the inertial or ground frame. And to do this, I used a laundry basket and tennis ball. So to set up my experiment, you need a ball. I used a tennis ball, a laundry basket, something that can slide, something to create a track to hold the ball and guide the ball's motion. I used a toilet paper and paper towel rolls, a ruler to measure distance, a phone with a Firefox app, an additional camera to record the experiment, and tape. And you can see the materials here, excluding the phone and tape and ruler, and my setup here. To perform the experiment, first the setup, I taped down the paper towel tubes next to each other at approximately the width of the tennis ball, and I placed a toilet paper tube behind the ball to hold the ball inside the track. And again, I placed the tubes such that the tennis ball starts at the middle of the laundry basket, which we're going to take as the origin of our body frame. Using the middle of the laundry basket as the origin, I used a tape measure and used a tape and ruler to measure out increments of 12 inches and mark with tape on the ground, as you can see I did here. And then make sure you have the Firefox app downloaded, open the gyroscope feature, and tape down your phone to the bottom of the laundry basket next to the starting point of the ball, as you can see here. From the actual experiment, place the ball at the starting point near the center of the basket and align the center point with the first tape marker, as you can see here. Recording the motion with the camera and using the gyroscope recorder on the Firefox app, apply a force to the basket that causes it to move forward and rotate, and I pushed the basket with my foot. Stop the gyroscope and export the data. After the experiment has been performed, record the distance that was traveled by the center of the laundry basket and by the ball using the ruler for your measurements, and repeat this two more times for a total of 3 trials. So here are the 3 trials I did. You can see me pushing the laundry basket with my foot to rotate the basket and cause the ball to move with respect to the basket. And here you can see the output graphs from the Firefox gyroscope data. So this is angular velocity about the z-axis, which is coming out of the ground straight up. And you can see in 2 of the cases I had a negative angular velocity, and in the middle case I had a positive max value of angular velocity. So I first calculated the velocity of the tennis ball in the body frame with respect to the laundry basket, and then the velocity of the basket with respect to the inertial frame or the ground. And to do this, I used the formula that velocity is equal to distance over time, and I found that the time of motion by looking at the video, going frame by frame, counting the number of frames that the ball was moving, and then counting the number of frames that the basket was moving, and dividing that by the frames per speed of the video, which was 30. And then I recorded the distance traveled, and then using those calculations, I used this equation to find the respective velocities. And here I have all these terms that I need to apply my equation. And here you can see the reference axes that I defined. So this is the body frame of the laundry basket, and this is the ground frame. This is the velocity of the origin of the laundry basket with respect to the ground, and I assumed it moved in the I direction. This term is the velocity of the tennis ball with respect to the basket, and it was in the B2 direction. This term is the angular velocity measured by the Firefox app of the laundry basket with respect to the ground. And this is in the k-hat direction, which is the same as the B3 direction. And then the position vector from O prime to P is I took the ball to be here at the end of the tubes. That's where I'm taking the velocity. So this is 12.1 in the B2 direction. So that's this distance here in the B2 direction. And then I use this equation and these values to find, again, the velocity of the tennis ball in the ground frame. So taking all these values where we have the ball moving in the body basket frame, in the laundry basket body frame, and relating that to the ground frame. And you can see here the results in inches per second. And notice that I had to write it in 2 different body axis systems, but this result still holds to find the velocity of the ball in the ground frame. And this is an example calculation for trial 1. Here I've listed some of these first theorem limitations in our experiment. Just want to highlight 2 of them in particular: the fact that the movement of the tennis ball in the slot and the angular velocity of the laundry basket are not totally in sync, as you can see in the video. And then we use the average velocities and the peak angular velocity and assume those were the values of the position chosen. So even though if these values are not totally correct, we make the assumption to allow us to do our calculations and get some results from our experiment. Relating this to aerospace, so essentially, again, any application where you're calculating the velocity of something in the plane from a different frame, likely the ground frame. So maybe you're in the military and you're at a station on the ground, and you have a soldier who's jumping out of the plane, and you know the angular velocity of the plane, the velocity of the plane, and the velocity of the running soldier with respect to the plane, but you want to find his velocity with respect to the ground so you can better track his motion and make sure he lands in the correct spot. You can use that. You can calculate those values and use the equation that I presented earlier to do that. A similar thing would be, you could do the same thing for unloading cargo mid-flight. So if you're unloading fire retardant and you know the angular velocity of the plane, the velocity of the plane, the position vector, and the velocity that the fire retardant is moving with respect to the plane, you can find the velocity of the fire retardant with respect to the ground frame and better figure out where the fire retardant is going to hit the ground and make sure that's accurate. You can also, maybe there's sensors on a plane where we want the velocity with respect to the frame, and we have the with respect to the ground frame, and we have our values described earlier. We can use that equation to find the appropriate velocity in the frame that we want it in, and etc. With other applications. And then here are my sources and inspiration for this presentation. Thank you.